Hi, Dan. Can you hear me?
Hey. Yes, I can.
Okay, great. So you're the first one in. You get first question.
Oh, sweet. Um, okay, let's see. So I did get your email. I know my hypothesis is late. It's just I kind of spent all weekend trying to I can navigate because your directions are clear. It's just I am so bad with hypotheses.
Well, so this hypothesis is pretty straightforward. You just have to decide what you think about the quality of water in the stream before you carry out any analysis. Um, and the analysis that we're doing is heavily reliant on nutrient concentration, which
Mm-hmm.
comes from agricultural runoff. So ask yourself, if you were to walk down to the stream in Proctor Park in the city of Utica, would you drink the water?
Mm-hmm.
Would you?
I would say probably not.
And why wouldn't you?
Probably just because I feel like there'd be a lot of bacteria and
Sure.
stuff like that.
Right. So what's a way that you could kind of summarize all of the dirty things that might be in the water? You could say it's most likely what?
Uh, is it? Would it be like the benthos or the plankton? Is that what you? I
Well,
see
no,
that
I'm
in the
saying
manual here. Or you
what
just
type of word could you use to describe the water as to why you wouldn't drink it? Like, I'm not going to drink that water. That water is blank.
It's murky.
Hi, Matt.
Hi.
Welcome.
that's what I
Murky.
was thinking.
Mur- um, what about something that maybe like do you think maybe you might get sick from drinking it?
Could, yeah, like beaver fever or whatever that is.
Sure. So there's a lot of words you could use: contaminated, polluted, you know, dirty, honestly. And then the nutrients are a measure of how contaminated or how polluted that water is. And once you have that data, then you analyze that data and you say, well, it is or it is not polluted based on, you know, a constant. So your hypothesis, it's very simple. Hypothesis of this study is Starch Factory Creek is polluted. That's sufficient.
I was way overcomplicating that thing. I was stressing the crap out of myself.
Most students do. It is just a very short statement about your guess, your suspicion about the conditions,
Hmm.
in this case of the stream, before you actually carry out any analysis.
Yeah,
So
I was going through like the definitions and like tables and stuff, and I was like, I really.
yeah, it's not that complicated. Don't make it harder than it is. Just what do you think about it? Is it, would you drink it? Would you not drink it? Do you think it's pristine drinking water? Is it clean? Is it dirty? Whatever your guess is, it doesn't matter because you just state your assumption, and then later on in the discussion you determine whether or not your assumption was correct, whether it
Mhm.
was supported or rejected based on the evidence, the data in this case.
Okay, that's a big relief.
Good. All right, good. So now you can go ahead and write that.
Okay, I will do that.
Good. Matt, what about you? Do you got any questions for me?
Um, when is the whole lab report due?
Okay, so the whole lab report, the final draft, is due end of next week. So let me look at my calendar really quick.
Is it the
So
7th?
it might be off the top of my head, I don't know the actual date But we do the lab report over the course of 3 weeks because it is a doozy of a lab. So
Yeah.
yep, the 7th. So March 7th. So at the end of this week, there's you should be doing the discussion forum on the helpful resources. And then you should definitely be getting started writing, your introduction, and then starting to review that data so you can work on your results section. And then by next week, even this week, if you can get around to it, but definitely by next week, you should be working on the discussion section, is where you actually have to work through that thought process of what does this data mean?
Okay.
Yeah, so you got 2 more weeks to go.
All right. Another thing was I emailed you about the soil analysis lab.
Yeah.
Yeah, I tried clicking on the video links and stuff, and it kept bringing me to like an error page.
I'm not sure what's up with that. I just emailed you back a little while ago. I tried both links in Soil Analysis 1 and Soil Analysis 2, and both of them are working on my end. So,
all right. Does
go ahead.
does it bring us into like the MV like library system where you have to put in a password and stuff? Watch it.
It shouldn't do that. It should take you right to the so the Soils Analysis 1 is going to take you to the Academic Video Library, which is a tech resource which should not require a login.
Okay.
And then the other one is going to take you to a YouTube video that I created. And it might be the browser you're using, or sometimes browsers just get like backed up and then they don't want to work. So if you exit out and then restart the browser, sometimes that works when students have this issue. If you try both those things and you're still having trouble, just contact somebody in IT. Sometimes student Blackboard's accounts get wonky and they have to be reset for things to work. I don't know why, but it's nothing I can do on my end. So try those 2 things and let me know if you get it resolved.
Okay.
Cool. All right, other lab report questions?
Oh,
I think I'm
about to
good.
go insane.
All right, let's see. We got Dawn waiting to come in. Let's see if she has any questions. Hi, Dawn. Gonna unmute you here.
Okay.
How you doing?
Good. How are you?
Good. So we actually just had a break in the action. Do you have any questions?
I don't know. I guess I'm just kind of like lost on the whole way of doing it. I actually found the other video that you had posted after I did the first little statement, and then I went back and redid it.
Okay.
It's confusing just because I can't physically go do it, I think, is part of my confusion.
Oh, right. Like you can't go down to the stream.
Yeah, so like I'm reading some of the stuff, but it's like I can't picture it. I'm a very hands-on learner.
I know. That's why I did my best to offer some videos in each step that kind of show, okay, here's what you would be doing. So let's take a look at that. I'm gonna call it up and then share my screen. Just give me a second. I actually recently I watched a little video, and it was like every professor in a Zoom meeting. Hold on, let me share my screen. And it's so true, because Zoom, you have to get like the right screen up. Hang on one second. Babe, can you try to get her to stop screaming? Sorry, I have a 5-month-old and she's unruly. Where am I going? Okay, we wanted to look at the videos. Okay. So, stream analysis. Okay, I think I can share now, and then you guys can kind of see me navigate. That might be helpful. Screen share. I want to share this one. Yeah. Okay, so can you guys see basically the Blackboard site? You see stream analysis up top here? We can all, okay. So we go to this folder, And then if we come down in here in the lab report supplemental material, that's where all the videos are. But first I want to draw your attention. I'm going to go back actually to the directions because the links are also in this file. So if we open up this file, all of the kind of hands-on stuff that we would be doing is here in these videos. So the first week of this lab, we actually just do practice with the machinery so we know how to use it. And that's here in this very first video for introduction to test equipment. And you watch that, it's a guy in a lab setting kind of doing the analysis on water in the lab. And then these ones are a couple of women who actually go down to a stream and they carry out some of the stuff that we would do. So there's a handful of videos here to kind of show you, okay, here's what we would be doing. We can't do it right now, but if you were to go to the stream, here's an example of the types of analyses and, you know, kind of the procedure that you would be following. So these 3 videos right here under stream analysis 1 for the abiotic parameters, that's where we're taking nitrate, phosphate, dissolved oxygen concentrations. That's where we're getting flow rate, widths, and depths, and all of the data that you see compiled at the bottom of this document. So it's not ideal. Believe me, I'd rather be going to the stream too. But this is what we're working with. So you kind of just watch those and go, oh, okay, envision yourself if you were doing it too. And then down here a little bit further, this shows you Proctor Park in Utica, which if you want to, feel free to go there. We can't go there as a class, but it's open. You can go hike around. And this is, I highlighted the creek. You can, you park, there's a little parking lot right here off of Rutger, and then you kind of just walk down to the water's edge there. And then on this map, I've kind of shown a blown up version of where we would as a class be taking samples. So A, B, and C are where we would have 3 different groups broken up taking the samples. And then now we have the data. So you'll see, okay, this was groups A, nitrate concentration, this was groups B, nitrate concentration, and this was group C. So as you look through this data, this is just like a data log. You need to take all this data and compile it into a table and then do an average. And so if you want to see what I'm talking about there, I'm going to call up your lab book. I'm going to just call it up from my files because it'll open faster. You guys know you have this on the lab site. You have this whole document. Let me see where that is. It's right here. So I'm going to cruise down, forget exactly what page number this is on. So stream analysis, so somewhere around 103. There we go. So there's a picture of, you know, if it was you, what you'd be doing. And down here is an example of the data table. So use your lab manual as the guide for background information, things like that. And then the data that I provide for you in the directions, you're going to take all of this and you are going to compile it into that. Does that make sense for you 3?
It does, yes.
Okay, good.
Yeah.
Yeah, that clears up a lot of what I was questioning too.
Okay, good. I know I did my best to put it in words in the directions, but I know sometimes it's like, there's so many documents, especially with all the videos too. So I understand that. Okay, and so then the other thing, because more data, right? Then you're also going to have biotic data, which is the living stuff. Oh, and let me make a mention. So a couple students, they do this. We refer to abiotic as organisms. Don't do that. They're not organisms. That's just for anybody who's going to listen to this recording later. it's hard to describe abiotic, right? Because we want to say like, well, we have organisms and we don't have organisms. We have things that are alive and we have things that aren't alive. The abiotic aspects, conditions, parameters, any of those words, or use those words, they are not organisms. They were never a living creature. So it's not correct to refer to them as an organism. So just as you're writing, just don't call them that. You can call the biotic organisms because they are. And biotic also includes things that were once alive but then also died. And it actually includes their excrement. Whereas abiotic is nitrate, phosphate, width, depth, flow rate. Those things aren't alive, never were. So just a pet peeve, and I have to take off credit when students say abiotic organisms because they don't agree. They're not the same thing. So just FYI for everyone. And then for your biotic data table 2, you're going to break things down into these 3 categories as you see them, into a data table similar to this. But if you look at your guidelines, you'll see that it's broken up a little bit differently, and I'll call that up. Let me call up your guidelines. And just so you know where they are, here, we'll go back. You guys can still see my screen, right?
Yeah.
See all the changes I'm doing? Okay, so if we go back to your lab site and we go into the test equipment and stream analysis lab folder, and we download in this folder the guidelines and resources, the one with the rubric. This is the follow this guide. Okay, I'm going to open that up, and this is the one that I wrote. Some of the other stuff that's in here is another professor took this lab and added and changed a few things, and I liked some of the changes she did, but I deleted some of the other stuff. This is the guideline that I wrote, and it includes the rubric that I use to grade you. So it's really important to pay attention to this file. And so if we cruise down to the data tables, like I kind of shortened them, I abbreviated them here. But you can see for data table 2, we have the 3 categories: phytoplankton, zooplankton, benthos. And this is where you're going to insert an image of the critter. And to make your life easy, those critters are already on your direction. So I cruised back to the direction file. And so if you look, they're already here. You just don't know what they are. So you can take this image, copy and paste it into your data table, your biotic data table, but then you have to identify what it is. And how you do that is, let's get back into that folder. Oh, not that file. It's this folder. So here's the material and data. So this is where I said earlier on the direction file, I have all the videos are linked. Those videos are repeated in this folder. So just another way to access them. And then also here's the biotic data. It's a Google file, just another place to access it. And these are your organisms. So see the Stream Life biotic data, Stream Life biotic data. We have macroinvertebrates, which are the things you can see with your naked eye. And then we have the microinvertebrates, and those are the things that you need the microscope for. So if you open up these files, you will see the names of all the creatures. Now, there are more creatures in these files than there are in your data, because you got to go look at these and find out what you have. So let's do one together. So we'll look at this creature right here. I'll just blow that up so you know which one I'm looking at. I'm just gonna get rid of that guy. Oh shoot, that screwed up my screen. There we go, this guy. Okay, so take a good look at him. And then we'll go back to this thing now. Let me see, for some reason, there we go, that's a better view. Okay, so we're gonna cruise through. You guys, so turn your microphones on. Say stop when you think we've gotten to the creature. Okay, that's the end of that file. So let's,
Definitely
we passed it. It's okay, we'll look at it again. Here it is. Okay, so let's check it out. He's got kind of a flat head, 6 legs. He's got these 2 little tails here, 2 antennas, and he's kind of broad. Okay, now they don't always look perfect, just FYI. So let's go back to the document, and I'll go slow again. You guys can you see the critters okay on your screens?
Yeah.
Yeah.
Okay. Okay, so is it on this page?
No.
Nope.
No. Is it on that page?
No.
No.
Nope.
Nope. What about here?
Nope.
No.
Nope. Here?
No.
No.
Nope.
Definitely not. Here?
No. I don't think so.
Questionable. Let's keep going. Here?
Yes.
Which one?
The left
One.
one.
Left.
Yes. Now, how might you tell the left from the right? You can kind of look at some body variation. This one has those 3 kind of partitions. This one only has kind of more like 2. And so if we look back at that creature, he definitely has the 3, okay? And the coloring's correct. And you can see the 2 tail appendages and the 2 antenna appendages. So in that case, you would say this is common stonefly. And so in your data table, and this is a big guy, okay? And you're also going to notice the document that this is on. Let me cruise this back up. What does this say up here?
Benthic.
Benthic. So that's one of your benthic creatures. So that tells you what category to put it in. And then this is where you get that creature's name. So in your data table, you're gonna, under the benthos, copy and paste the image and then just type in common stonefly. Cool?
Mm-hmm. Yeah.
Now, do we have
So-
to draw it too?
I did want you to draw it. We always draw it in class because we have the creatures in front of us and we do a little hand sketch and then we go and we identify them. If you can draw, I mean, you can draw it in a program, you don't have to, but if you can just do a little sketch, take a picture on your phone, and then, you can send that image to yourself somehow, or I don't know what type of devices you have, but even if you have like a digital camera, however you can get that image, if you want to draw it in paint, pretty much any way you can get a little sketch is acceptable, and they don't have to be perfect. As long as there's a sketch, that's good. All right. Any other questions?
Not for me right now, no.
Yeah, I think I'm good for right now too.
Yeah, I'm good.
Okay.
Yeah,
I
that
got
cleared
one
up
other.
a lot.
Oh, go ahead.
I just said that cleared up a lot, so.
Oh, good. I have one other thing in my head as you guys prepare to do your discussions that I want to review really quickly. Okay. So let's go to the lab book. And I just want to point out a couple things about, you might be wondering, well, what am I supposed to compare my results to? Your lab book is handy. You can use this, and I'll show you where it's discussed. And if you want to use any other reputable resource, if you want to use EPA standards, that's absolutely fine. If you want to go to waterontheweb.org, that's a really handy website for all types of water quality questions. They will have concentrations. Depending upon who you ask, every concentration is different. But what is in your lab manual is generalized, and the EPA is a little bit more strict about what would actually come out of our tap water. We just had another student come in. So let me show you up here in test equipment. I'm just going to cruise up there at the start of test equipment. So just so you know, this is Introduction to Field Testing Equipment. This is the precursor lab to your stream analysis lab. Down here in nitrate, in the second paragraph, it says the let me get that out of the way. The maximum levels permissible for drinking water are 45 milligrams per liter. You can use this, and you can reference your lab book as the source for that acceptable concentration. For your data, let's go back to your data. So you're going to take nitrate, compile it into your data table, carry out an average. So add all these three up together, divide by 3 and get an average. And if that average is above 45 milligrams per liter, is it drinkable? Yes or no? If the
Yes.
average is above, can you drink it?
No.
No. And if the average is below, can you drink it?
Yes.
Yeah.
Yes. Okay. So phosphorus. Right here, levels above 0.25. So it's a really tiny amount with phosphorus. Indicate a eutrophic lake. And that means high levels of nutrients that do all these not good things. So eutrophic is basically a big fancy word for polluted. It means nutrient rich. And this can cause all types of different consequences for the aquatic ecosystem. Algae blooms lead to blocking out sunlight. It just is a general decline in water quality. So eutrophic kind of is an all-encompassing word there. So above this would be considered polluted. Below that would be an acceptable level for the aquatic environment. Does that make sense? Cool. And then the last thing, a lot of times students have a little trouble with oxygen saturation. Oxygen saturation is just how much oxygen the water can hold. And we can mess with this number in 2 ways. We can agitate the water. Increased flow rate leads to increased agitation, which adds more oxygen to the system. So ponds are going to have less oxygen than flowing water, so long as they're at the same temperature, because the other way that we can mess with it is with temperature. If you heat up the temperature, gases expand, so they take up more space, and you can't fit as much in the environment. So the hotter the water, the less the oxygen. We figure out saturation point just to see a measure of how saturated that water is. Is it fully saturated? Is it less saturated? And what does that mean in terms of the environment? It can mean it's really hot. It can mean it's stagnant. You know, the opposite would be it's really cold and it's fast moving. That's not an indication of water quality. The amount of oxygen is. So down here in the reading, it says right here, concentrations below 3 milligrams per liter are avoided by many fish when possible. So why are fish going to avoid waters that have less than that amount of oxygen in it?
Because they're not habitable.
Because they're not what? Sorry.
Habitable.
Yeah, and why isn't it habitable? What does the fish need to do?
You need oxygen.
The fish needs to breathe. Yeah, it's that straightforward. So if concentrations drop below 3 milligrams per liter, fish can't breathe. That's why they avoid those portions of an aquatic ecosystem. So that's kind of the thought process. So if you're going to report dissolved oxygen in terms of its amount of saturation, but then when you discuss it, you're going to discuss it in terms of, is it habitable? Is there enough oxygen for the aquatic ecosystem to survive? And this is an acceptable concentration to use. If it's above, it is, and if it's below, it's not. So that was the last thing I wanted to make sure I mentioned for you guys as you move forward. Do you all, anybody else have any questions for me?
Yeah, I actually had a couple questions. Sorry I joined in the Zoom late. I just saw your email.
That's okay.
So about writing the hypothesis.
Yep.
Like it took me a while to figure out where to find all the data and everything for this lab. What
Yep.
is our hypothesis based off of?
Okay, so with this experiment, right, we are measuring the quality of water in the stream, and we are doing it based on nutrients. I just got the 10-minute warning from Zoom. My apologies. So nitrogen and phosphorus are indicators of water quality, and they make their way into aquatic ecosystems through natural processes like breakdown of phosphate-bearing rocks, the nitrification process of bacteria in the soil, but also they get enriched from agricultural runoff. And when waters become enriched with nutrients, it creates a polluted environment that maybe is detrimental to the health of the ecosystem. So your hypothesis should reflect water quality. And what we discussed at the beginning here is about, you know, would you drink the water in the stream in Proctor Park? How do you feel about that, Eddie? Would you drink the water?
No.
Yeah, and why wouldn't you drink the water?
Well, like that's what I was asking. So we'd base our answer off of the data and the concentration of everything.
So, okay, no, you're not actually developing your hypothesis based on data. The data has been provided to you because we can't physically go down to the stream and do the experiment, but you design your hypothesis before experimentation. You don't obtain data until you carry out an experiment. So when you write your hypothesis, no experiment has been conducted yet, and you are essentially guessing, you know, based upon background information, what you feel the outcome is going to be. Then once you experiment and collect data, then you analyze that data to determine if your guess or your suspicions were correct. So when writing the hypothesis, completely ignore the data.
Okay, gotcha. So if this experiment was to take place in real life, we'd be analyzing the water in the Proctor Park stream.
Yep. Yes.
And now the full lab report and everything is due next week, correct?
The 7th, yes. And is that, you got some more?
No, I think that pretty much sums it up. I was just wondering where, like, since we can't actually conduct the experiment, there was a lot of different links and a lot of different things
Yes.
to watch. So I was confused as to where to find the data and where to, you know, like put it all.
Good. Yep. So we reviewed all of that throughout the meeting. So I'm gonna ask you to watch the meeting from the beginning, because we are almost out of time. And you all of that will be answered. Those were all the same kind of questions.
Okay, thank you.
Yep. No problem. All right, you guys, anybody else got anything else they can think of before our 6 minutes are up?
Not for me, no. If anything comes up, I'll probably just shoot you an email.
All right, cool. Everyone else is good?
Yeah, I think I'm all good.
Great. What do you guys think of my background?
It's cool.
You know what this is? This is dinosaur.
It's not real, is it?
It's what?
Is that real?
Yeah, that's real. I took this picture on a field trip with geology students. This is Alameda Parkway in Colorado, just outside of Denver. And those are real dinosaur footprints. And you can actually put your hand in them if you ever go visit there.
Wow.
Yeah, I
That's
always like
cool.
to point it out because it's cool.
Yeah, it is cool.
Awesome, yeah.
Well, it was really nice to meet everybody. I
Yeah.
really wish we could be in person, you know, personally, but
Yeah.
Yeah,
the
me
times
too.
we're living in.
Yeah, right?
So and this obviously goes for the whole class. You guys, if anybody has questions or you want a little bit more information, you know, my office hours are by appointment. I just need a 24-hour notice, so I can, you know, schedule you in. Sometimes I can do it that day. It just depends on, you know, what's going on that day, because schedules are crazy in this online world. But yeah, if you have trouble or anything, just shoot me an email. And if you want to meet face to face, you just let me know.
Okay. Is this Zoom recording going to be posted and announced?
Yeah, so it's going to take a little bit to load because it's almost an hour of recording. So give it a little bit. It should be up as soon as it's ready.
Okay, thank you.
Yep, no problem.
Thank you very much.
Thank you.
All right,
Yes, thank-
everybody. Good luck with your lab report. Have a great day.
You too.
Thanks.
You too.
Bye.